Welcome back to the Introduction to Inference, Part 12. We're going to start off with looking at the Minitab commands that will help us find the p-value for our hypothesis tests. Right here you see with the different lines of the command to do this. On the first command line, we put that it's the 1z, that's one word, test. In other words, one sample z tests. Now what makes it a one sample z test? Let's go back and say, well, we have to have three assumptions that have to be met. The first assumption is that our sample is obtained from a simple random sample or a randomized experiment. Number two, that the sampling distribution of the sample mean for samples of whatever size n, has to be normally distributed or approximately normally distributed. And the third condition that needs to be met is that our population standard deviation is known and is given to us. Now let's go back to condition number 2. How do we know something's normally distributed or approximately normally distributed, that the sampling distribution, that is normally distributed or approximately normally distributed? Well, to know that it's normally distributed, the parent distribution would have to have been normally distributed. If our sample size is 30 or more, in Stat 250 we said that makes the sample size large enough for us to evoke the central limit theorem. So for number 2 to be true, either our sample sizes are greater than or equal to 30, or we know that the parent distribution is normally distributed. So let's go back to our Minitab command. So 1z, with those three conditions met, we can use the 1z command. And then the next two things you have to input is the sample size and the sample mean. So n for the sample, x bar for the sample mean. Then we put a semicolon because that lets Minitab know that we want to give it more information. So our next line, it could either be sigma test or alternative, any one of those interchangeably. We'll put in the sigma. So you could either have written the whole word out or just the first 4 letters of the command. I tend to like to write the actual command word out, but you can do what you like. So you write sigma, and then you input what the population standard deviation is in the problem that you're doing. Semicolon again, because you got to tell Minitab more information. Test. What is that? That line's to let it know what the value of the null hypothesis mean is. So the mean of the null hypothesis is your mu, mu naught, the status quo. So you put the value of your null hypothesis in there. Semicolon again, because right now Minitab could calculate the test statistic, but in order for it to calculate the p-value, it has to know whether it's a left, right, or two-tailed test. So we need this fourth line, which is the alternative. In other words, what's the alternative? A right test, a left test, or a two-tailed? And in Minitab, that w, that value that you're going to put in w, is going to either be -1, 0, or 1. If you put in -1, you're letting Minitab know it's a left-tailed test. If you put in 0, you're letting Minitab know it's a two-tailed test. And you put in a 1, you let Minitab know that it's a right-tailed test. So let's look at an example. In this problem, it says the ATM of a certain type of ATM machine reports that the mean ATM withdrawal is $60. A manager of a convenience store with an ATM machine claims that the mean withdrawal for his machine is less than that amount. He obtains a simple random sample of 35 withdrawals over the past year and finds the sample mean to be 52. Now assume that the population standard deviation is 13. Let's test the manager's claim at a 0.05 significance level using the p-value approach. So first of all, are the conditions met so we can do a 1z? Well, it says right here, he obtains his sample from a simple random sample, so number 1 is met. I see the sample size is 35, so since the sample size is 30 or more, I automatically know that the sampling distribution is at least approximately normally distributed. We have a population standard deviation, that's condition number 3. They give it to us as $13. So I am now able to put all my information, because they gave me the sample mean, we got the sample size, everything. I can now use my Minitab command and find the p-value. Now up above here, we see the commands. 1z, there's my sample size, 35. There's my sample mean, 52. You see the semicolon letting Minitab know, hey, I got more information to give you. And I put in my sigma. My sigma was 13. Then my next line, I put my semicolon in, I put my next line, well, the value in my null hypothesis was 60. And the alternative, remember, the manager thinks his ATM is less than 60, so the alternative would be -1 for a left-tailed test. What will pop out of Minitab is right here. And the things that are important is the z-score, or the test statistic, your z-naught. It's -3.64. You almost don't have to look any further. That's way out in the tail end. And if you look at the p-value, Minitab, it is so small, Minitab, it's less than 3 decimal places, virtually 0. What you would put as your p-value is less than 0.0001 when you see this here. So since that's much less than your alpha, remember we chose an alpha of 0.05, we're going to reject that null hypothesis. So you would say there's sufficient evidence at a 0.05 significance level to support the manager's belief that the mean ATM withdrawal is less than 60. Now let's look at a Minitab problem where we are given raw data. We find out that all the conditions are met, and our data is in a column in Minitab. Well, it doesn't look very much different, except for Minitab will give the n and the x bar. It will actually calculate the sample mean and pick up the sample size. So you would write 1z, that's one word, and then you put the column that your data is in, and then everything else is the same. End of apple juice is supposed to have 64 ounces of juice. Because the punishment for underfilling bottles is severe, the target mean amount of juice is 64.05 ounces. However, the filling machine is not precise, and the exact amount of juice varies from bottle to bottle. The quality control manager wishes to verify the mean amount of juice in each bottle is 64.05 ounces, so that she can be sure that the machine is not over or underfilling. She randomly selects 6 bottles of juice, measures the content of each. The data is found in, this is where it's found on your in your Minitab examples, is Minitab 11 data. That's for chapters 14 and 15. Now assume that the standard deviation of the population is 0.04. Perform the indicated hypothesis test at a 0.05 level of significance. Now a data analysis was done. What that tells us is the data is approximately normally distributed. Let's open up Minitab and put what we need in there. So it's a 1Z test. My data's in column 1. I am going to put the sigma in the problem, which is 0.04. I'm testing the value of 64.05, and this is a alternative, is a two-tailed test, 0. Hit enter, and there we get our z value is -2.35, not looking good for the null hypothesis, and the p-value is 0.019. So at a 0.05 significance level, the p-value is much smaller than that. There is sufficient evidence to support the claim that the machine is not filling it correctly and adjustments have to be made. And there you see that.